Performance, quality, and reliability are a part of every product.
Hi, I'm Irvin Gers with Raybestos Powertrain. Today we have a unique opportunity to look at a failure that is going to occur. And I say is because, as you can see already, we have a piece of friction material missing off of this damper assembly. Now this damper assembly comes off of an Allison 3000, and it is considered to be a dual clutch assembly. And the reason for that is we have friction material on both sides. Now because of that, we want to see if the problem is localized on the one side, or maybe it's just that that's the first side that ended up with the problem. This is a unique damper assembly because it is riveted together, as we can see here. And notice that in between these two rivets here, this is where the material came off. So already that raises a flag. Upon closer inspection, I noticed that there's a gap growing in between the rivets right in the area where this debond occurred. I cannot put my feeler gauge in there, but I can put it in on the other side a little bit right there, and I can put it in on this side. So I'm going to go into the lab area with this, and we're going to take a closer look at some of the other things we can with some specialized lab equipment. And yes, we understand that you may not have this ability to do this, but this is something that I need to show our customer that we took every measure we possibly could to try to prove what is the root cause of his problem. In the Raybestos Powertrain Lab, we tested the Allison dual clutch assembly to determine surface flatness, to detect any issues with the thickness of the friction material, and to evaluate the surface finish. We conducted these tests with and without the original friction material. Without specialized equipment, you can use a straight edge to check surface flatness. We discovered that the surface of the Allison assembly was not flat, and the surface finish did not meet our optimum bonding specifications. For more information on creating the best surface for a successful bond, please see our torque converter video available at raybestospowertrain.com. Bond test number 1. Net facing pressure 200 psi. Now that we've completed our testing on our bond on the assembly, I actually was able to peel up some of the material. So after further checking, what I was able to determine is that using the minimum spec of 200 psi, we still have a bonding issue at this same spot on the assembly. So what I'm going to do is I'm going to strip this down again, and I'm going to do another bond, but this time I'm going to bring the bonding pressure up to 250 psi and see if that helps or doesn't help at all. Bond test number 2. Net facing pressure 250 psi. Now that we've been through the process of checking our surfaces, cleaning, and all that, we're ready to bond some new wafers to this. Now because of the previous checks that we did, we determined that the flatness of the surface is a little bit on the questionable side, so I'm going to set the bonder up for the 250 psi bonding range, and we're going to see what happens. Increasing our net facing pressure to 250 psi gave us some improvement over the results we achieved at 200 psi, but we still need a better bond than this. Bond test number 3, net facing pressure 300 psi. In our previous segment, we bonded our torque converter rings at 250 psi, and we got a better bond than what we did at 200, especially in light of the fact that we have such an irregular surface. It's not flat. The surface finish is a little bit smoother than what we want. So basically what I'm doing here is we're going to test this at 300 psi. Now I know that we've set recommendations in the past, 200 to 250 psi net facing pressure with no more than 275. But because of the condition of our assembly, we're trying to think outside the box a little bit. But I'm also doing this with a factor of safety, simply because I know that it's not going to hurt this material, because we've already done some preliminary checks on the material to see if it'll withstand those kind of pressures. Increasing the pressure did not improve the bond on our trouble spot. We'll need to address the condition of the assembly itself. Bond test number 4, corrected surface. Net facing pressure 200 psi. We've taken it to the next level. We've actually taken this assembly and turned it on the lathe. And I've got one side is roughly about 140 microinches, and the other side unfortunately is a little bit higher. It's at 200, but let's see what happens if we go a little bit outside of the specifications. So with a corrected surface, we bonded the assembly again, returning to 200 psi for our net facing pressure. So far the bond looks good. So as you can tell, our area before, we were getting a little bit of a bare spot, and now it looks like we got a much better coverage all the way across from the ID to the OD. So I would say we definitely got a much bigger improvement on our bond simply by turning it on the lathe. So there you have it. After extensive testing, we were able to determine that our assembly needed some work. The surface was not flat by any means. The surface finish was questionable for a good bond. We decided to take it to a machine shop and have it set up in the lathe. After the machine shop, we were then able to get a successful bond. If you're experiencing bond failures, what you want to do is you want to go back to the basics. You want to make sure that your surface is flat. You want to make sure that your surface finish is correct. And you also want to make sure that you do a time and temperature study so that we make sure that we can get a bond line temperature of at least 350 degrees. And then you want to go at least another 2 minutes at that temperature to make sure you achieve that good successful bond. For further information, you can visit our website at raybestospowertrain.com.
And at Raybestos, performance, quality, and reliability are a part of every product.